Alright, cool beans. So, oh, yesterday's class, I was supposed to hand that back, shoot. Were there any questions when you guys were doing yesterday's classwork at all?
No.
No? So if I said someone hand it back, it'll be good?
Yeah.
Did you all check your answers with mine to make sure you had the right answers?
No.
Really hope you're, hey, would you hand these back for my chance? Alright, so if there's no questions on that, Kenny's gonna hand it back. If you do have questions at a later time, you can ask me, I have no problem answering them, but I'm gonna keep going to the lesson for today. So, today's objective is we're gonna use frequency tables as it relates to data, so using frequency tables to find the mean, median, mode, things like that. We're also gonna show you how to put those frequency tables in your calculator. And then we're gonna interpret data to find normal distribution. So normal distribution is like a bell curve. I mean, you've all heard of it before. We'll kind of take a look at that at the end. Frequency tables. So a frequency table is it's a table that tells you a score or some sort of number on one side and then the frequency on the other. The frequency is how often that thing happened, right? So if we have a frequency of 5, that means I got a score of 2, 5 different times. So when I go to write out my mean, I can go 1 plus 1 plus 2 plus 2 plus 2, so on and so forth, writing them all out. 1 happens twice, 2 happens 5 times, 3 happens 4 times, 4 happens 2 times, 5 happens once. Or you can multiply them out, divide by how many numbers there are, things like that. We're going to show you a couple different ways. This one's not actually on yours. I believe this one is. We're going to show you a couple different ways to find the mean. You could write them all out like we just showed you. You could write 1 out 8 times, 2 out 11 times, 3 out 4 times, 4 out 8 times, 5 out 5 times, and 6 out 9 times. Or, an easier way to do it by hand would just be to multiply across here. Multiply your score times the frequency. 1 times 8 will give me 8. 2 times 11 will give me 22. 3 times 4 will give me 12. 4 times 8 will give me 32. 5 times 5 will give me 25. Oh, that's a tough one. 6 times 9 will give me 54. And instead of writing them all out, adding them up, we're going to multiply across like that, and then add all those numbers up. That's going to be the total score that we get. The total number we rolled from all of our die. So once you add them all up, let me know what we get. 153? Is that a consensus? We'll add 153 in our calculators? Alright. So normally we say on the mean we add everything up and we divide by how many there are. So I'm going to take 153 and I'm going to divide by how many times I rolled the die. Well, how can I figure that part out? We figured out the scores, we multiplied them out and added them up. Colton, how did I figure it out?
Add the frequencies.
Add the frequencies, right? Each frequency is how many times we rolled that number. So to find out how many times we rolled the die, I'm going to add all the frequencies up. 8 plus 11 plus 4 plus 8 plus 5 plus 9. Go ahead and do that. What did you get? What? What do we get when we add all the frequency? 45? Everyone got 45? Okay. So what I'm going to do is I'm going to take 153 and I'm going to divide it by 45. The total number of scores divided by how many times I actually rolled the die. Let's round to tenths. I don't know. I don't know if it even comes out any farther than that, does it? No. Perfect. So, then, when I'm finding the mean, it's going to be 3.4. So 3.4 for my frequency table. So when you're doing your frequency table, doing it by hand, like I said, multiply across, add them up, and then divide by how many times you roll the die, or how many times you did a certain thing. Does that make sense?
Yep.
Pretty easy. You seen that before?
Yep.
Yeah.
Yeah? Alright, so that's by hand. We just did it by hand. Now let's do it in our graphing calculator. So, what I want you to do, in list 1 should go your scores. So scores should be list 1. Your frequency list should be in list 2.
Mister, you have a question.
What's your question?
So, I have like extra values
Okay,
in like one of the rows, like how do you get rid of?
if you highlight that value and you hit DEL, that's delete, should get rid of it.
You have to go up.
So you're trying to like get rid of these,
Or these, like the zero.
the zeros, and then just hit delete? And just like you go, oh, sorry. You go to like the top zero, and hit delete a bunch of times, like delete it. Okay. Alright, so 8, 11, 4, 8. Alright, so we know how to find mean normally when we just have a list in there, right? We talked about that already. So now we're going to do the same thing. Stat, calculate, one variable stats. My scores are in list 1, so that's my list. I want that as my list. So list 1 is my list. FREQ list. What do you think that stands for? Frequency list. So we put our frequency list into list 2. So now I'm going to go down to that. I'm going to put list 2. And now when I hit calculate, it should calculate my mean based off those frequencies. Yes, ma'am.
Your calculator doesn't have that.
You have that older calculator, right?
Yeah.
So when you get to your screen and it pops out one variable stats right here, you're going to do list 1, then you're going to do comma, list 2, and then hit enter. So like you get your one variable stats out there,
Oh, yeah.
list 1, then you get comma.
Sorry, Mr.
3.4.
Mr. I blank.
Same thing we normally do, just like stats, calculate, one variable stats,
Stat, calculate, one variable stats.
our list for list 1, and frequency list is in list 2. Did everyone figure out how to put it in their calculator? We all got it?
Yeah.
Okay, so you can figure out the mean of the frequency list by doing it in your calculator as well if you'd like. Alright, you should still get the same exact thing. Right, x over a line with it is our mean. We all got 3.4 in our calculators as well, right?
Yeah.
Good. Alright, so in your calculator you should still get 3.4. Alright? Any questions on that? Relax, fellas. What do you mean? So, this should be list 1, this should be list 2, right? Then our mean is X the line over, it's our mean. Alright, so let's do the next one. Mitch did a survey of the number of emails some pupils in her school had received yesterday. Frequency table shows the results. Work out the number of pupils Mitch asked. Okay? Well, someone help me out. How many people did Mitch ask? How do I figure that out? Add the frequencies. Add 1 plus 3 plus 5 plus 8 plus 5. Should give us 22, I believe, correct? So 22 people. Okay? Mitch thinks the average number of emails pupils in her survey had received is 7. Why is Mitch incorrect? Someone raise their hand and tell me why she's incorrect. Someone besides Cole thinks he's answered everything so
That
far.
is not a frequency.
Great.
Because nobody said they got 7.
No one said they even got 7 emails, right? The highest number of emails received was 6. There's absolutely no way our average or our mean could be 7. No one received more than 6. Alright, then the last step it wants you to do, calculate the mean. Now, I'm going to do it by hand. If you want to do it in your calculator, you're more than welcome to. Like I said, though, I'm going to do it by hand. So I know this one's 22. 2 times 1 is 2. 3 times 3 is 9. 20, 40, 30. 60, 90, 99, 101. So, total number of emails was 101. The people was 202. 101 divided by 22. 4.6?
Yep.
Did anyone do it in their calculator?
Yeah.
Did you do it in your calculator? Did you get 4.6?
Yeah.
Sweet. So we had the same answer. That's usually a good thing. Any questions on that? Nothing? No questions? Alright. Keep rolling then. Bar graphs, same sort of thing, finding it off our bar graph. If we're looking at a bar graph, how do we know which one has the most? The one that's the highest, or in the longest, it's going horizontally, right? So if I ask you what color is the mode, or which one has the most, what would you say in this bar graph?
Black.
Black. Right? It's the tallest bar. And then if I asked you how many people were surveyed, Tom, how do you think I can figure that out? Add them all up, right? Red has 5, blue has 4, green has 2, purple is 7, black is 8, and white is 5. So add them all up. 15, 20, 22, 26, 31. So there should be 31 people surveyed. Pretty easy so far, right?
Unless I'm like,
Any questions? Alright, the next problem is a really important problem. We're probably going to see it somewhere that's really important. So I make sure I pay attention. Missing data. So we've done missing data with the mean before, right? Where we add them all up and we add x on the end, solve for x. Now we're missing 2 pieces. What will happen with this is you will always need at least the biggest or the smallest number to do this. Okay? We are missing the range and the mean. So use the range and the mean to determine the missing numbers in each ordered data set. Well, I know the mean is -2. I know the range is 14. How can I find my numbers that I'm missing? Mason, what do you think? Never mind? Just stretching your hand up.
No, I think we just like take 5 and I think we do like 5 minus 14 for a range and look at like that number. Range is biggest number minus smallest number.
Range is biggest number minus smallest number, right? You will always start out by using the range first. When you're doing a problem like this, you're missing 2 numbers, you're going to have to start by using your range. Right? So we can't have 2 different variables in there.
Oh.
So what's going to happen is our range is 14. That should equal our biggest number, which is 5, minus our smallest number, which we don't know. So 14 should equal 5 minus x. Does that make sense? Right?
you find mean by
Well, let's start by finding our x value here. Okay? So let's subtract 5 first. 9 equals -x. Divide by -1 or multiply by -1, whichever you prefer. We get -9 equals x. So you're always going to use that range to find the smallest or the biggest value, whichever one you're missing. Then you can find your other missing value. And we're going to do that by using the mean. And I know my mean is -2. So if I add up all these values, including that missing one, so -9 plus x plus -2 plus -1 plus 0 plus 5, and I divide by how many there are. 1, 2, 3, 4, 5, 6. It should equal -2. Right? Does that make sense? All we gotta do then is solve for x. Times by 6 on both sides. I get -12 equals, what is all this? -7 plus x. So -12 should equal -7 plus x. Well, last thing I got to do then is add 7 to both sides. I get -5 is my other missing value. So -9 and -5. Like I said, make sure you're understanding what we're doing here. It's going to be on something important coming up. I don't know what that is, but... Alright? So, start with your range. Start by using your range, then use your mean to help you out. Okay? Any questions on that? Alright, we have one more thing to get through today. What time we got here?
34.
29. 29.
Fall asleep.
Alright. Normal distribution. So, normal distribution is very important statistical data. A lot of people call it a bell curve, right? It's a distribution pattern occurring in many natural phenomena, such as height, blood pressure, lengths of objects produced by machines, and etc. There's tons of different things that follow a normal distribution. Right? A lot of times, some classes in college, I don't think any classes here follow a normal distribution curve or a bell curve when they grade things. Some classes do. What happens is a normal distribution curve or a bell curve is the same on one side as it is on the other. It's the exact same. So if I fold it over, it's going to match perfectly. Alright? So the shape of the curve described as bell, and it said it falls off evenly on both sides. The normal distribution curve is centered at your mean. So whatever data you're talking about, it's centered at the mean. That's what the x hat over it, right? X at the line we talked about, that's the mean. So your mean is always in the middle of your normal distribution curve. 50% of your data is going to be on the right side, 50% is going to be on the left. Now in a normal distribution curve, 68% of your data is within one standard deviation away from your mean. So if I add and subtract one standard deviation away from my mean, 68% of my data should fall in there. Which means on either side of my mean should be how much? How big a percentage? If it should be the same on both sides here, and it's 68 in total, 34% should fall within one standard deviation away from a mean. On both sides. Now, I would write these percentages out, because I don't think we actually give them to you on there. I may put them below, because it's tough to see on that gray. But you will need to know these percentages. So 34% is within one standard deviation in one direction. 95% of all the data is within two standard deviations away. So the next one we're going to do is it's worth 13.5%. Because we want 47.5% on each side. And lastly, 99% is all within 3 standard deviations away. We're just going to go from 2 on, and it's going to be 2.5. I really should use a different color, shouldn't I have? Guys, the great thing here, when we're dealing with normal distribution, is if you can remember one side of it, you can remember the whole thing. It's even on both sides, right? So 34% within one standard deviation, 47.5 or 13.5% is next, then 2.5. They're approximations, right? They're not perfect. But a lot of things fall into this category. So, it's Furman. Yeah, right. So, like I just said, make sure you have those numbers on your paper. If you want to write it out again and a little bit nicer, we're going to draw a bunch of these and I'm going to label them with those numbers. But you're going to have to need to know those percentages. All right, 34, 13.5, 2.5. Okay, and we'll see how it works in a second. Does that make sense? Okay. Any questions before we move on to trying problems? Okay. So our normal distribution. First problem: the amount of time Carlos plays video games in any given week is normally distributed. If he plays video games an average of 15 hours per week with a standard deviation of 3 hours, what is the probability he'll play video games between 15 to 18 hours in a week? Well, first thing I'm going to do is I'm going to draw my normal distribution curve. Okay? Now, I know it's ugly. I know your pictures won't be perfect. Mine aren't perfect. Right? That's fine. So, remember, in the middle, we said was our mean. Right? What is our average or our mean in this problem? 15. So that's going to be right in the middle of my normal distribution curve. If I'm going one standard deviation away, that means I'm adding 3 to it, right? The standard deviation is 3. So I'm going to go 15 plus 3 will get me to 18. And then one more standard deviation away will get me to 21. And I'm going to do the same thing going the opposite way. 12, 9. Now, what I would do, and what I like to do, is I'd write my percentages in there right away. Just so I remember them. Right? You don't have to do it. I'm not going to require it. So 34, 13.5, 2.5. 34, 13.5, 2.5. So then what it asks us is what's the probability he's going to play between 15 and 18 hours in the week? Well, look on here. 15 and 18 hours is right here. What's the probability it'll fall into there? What percentage? 34%. So there's a 34% chance he's going to play between 15 and 18 hours in a week. Does that make sense?
That's it.
Yeah.
What do you mean, that's it?
I don't know.
Like, that's it with the problem, or like, that's all the time he's gonna spend on video games in a
No,
week? That's an absolutely ridiculous amount of time to play video games in a week.
Maybe for you,
I don't play video games.
you should have seen you in Fortnite.
Oh, you guys are all turds.
Yeah, Patrick was watching this video.
Alright, hey guys, what if it asks about more than 18 hours? Hey, what if it asks about more than 18 hours? What would you say?
10.5%.
What?
Would you add it?
Add them, right? Because it's more than 18 would be anything over here. Anything over here. So we're going to take 13.5 and we're going to add 2.5. So it would be 16%, right? So we got to kind of see, where does it fit into our graph? Where does it fit into our normal distribution curve? What if it said less than 9 hours? What would our answer be? 2.5, right? It'd be 9 hours less than it, and just 2.5 over there. Does that make sense? Yeah? Alright, let's try one more. At BMO Harris Bank, the ages of all new employees hired in the last 5 years are normally distributed. So here we go. Within this curve, 95.4% of the ages centered about the mean are between 24.6 and 37.4 years. So what that means is, if I go and I draw this, right, normally distributed, I know that 95.4%, or about 95%, are between 24.6 and 37.4. So 95% of my data is between those two. We want to find the mean age, and we want to find the standard deviation. How can I do that? Can you say it a little bit louder, Cole?
Add them up, divide by 2.
Add them up, divide by 2, right? Find the middle of these two numbers. If you find the average of those two, that'll give us our mean. So 37.4 plus 24.6 divided by 2.
31.
31?
Yeah.
We all agree? All concur? Alright, so my mean is 31. So I found the first part, 31. Now I want to find the standard deviation. Well, how can I do that?
With the curve of the ages.
How do I know by how much I'm going in each one of these?
Find the difference and divide by 2.
For which, find the difference of what?
37.4 and 31.
So if I find the difference of these two, I figure out how spread out these are, and I divide by 2, it'll give me this middle number. Right? It'll give me how far I need to go. 37.4 minus 31 should give me 6.4. And if I divide that by 2, I should get 3.2, which would be my standard deviation. Right? So it's telling me I'm going 3.2 between each one of these. So that put me at, was that 34.2? And 27.8. Alright? So we found our mean, we found our standard deviation. Any questions, guys? No? We're good?
We are good.
Alright.